Hello guys, welcome to Learn Extra Live. Wow, I'm excited to be here. This next to me is Tsepo. Hi Tsepo, how are you?
Fine, thank you. How are you?
Great. You guys already know that we have our presenter search. Tsepo is part of the top 10, guys. Like, this is awesome. How do you feel?
Yes, I feel so honored. Actually, I'd like to thank my friends on Facebook. Thank you for voting for me. Thank you. I'm here because of you. I don't know how to thank you again.
That's awesome, Tsepo.
Yes.
Thank you for that, hey. So you guys, thank you to you guys for bringing Tsepo on the show because he's excited to be here. I'm excited to be here. Tell us a little bit about yourself, just so we know.
So, okay, this is Tsepo. Tsepo is me. I'm from Pretoria in the north of Maupane. Hello, if you know me. Yeah. I'm quite an open person, vibrant person, enthusiastic about education, and I'm willing to learn more. So I'm a mindsetter. I've been a mindsetter for quite a while.
Oh,
so
wow.
I'm willing, since I completed my matric last year, I'm still willing to be a mindsetter again this year.
Wow, that's fantastic, Tsepo.
Yes.
You see, guys, he wants to be a mindsetter for life. And he says mindset really did help him in matric, in grade 10, in grade 11, whatever. So you grade 10s need to stick with us because then you're going to come this far. And you've just finished matric, hey?
Yes, I did.
And
it was
how was
awesome.
that?
I enjoyed. Everything was going cool. With mindset on my other side, things were easy.
Oh, that's fantastic. We're so excited to hear that. And you
Yes.
mindsetters already know that we will never, ever leave you, which is why you should join us on the page, guys. Today, Tsepo is actually going to be on the page to you guys. Chat to him. He's a mindsetter. He knows a lot.
Yes.
Chat to him about everything.
Yes.
Exponents, because that's what we're going to be doing today. Anything that you want to know.
Yes.
Ask him how it was to be in our mindset studio and to meet all of us. So, yeah, guys, chat to him on the page, www.facebook.com/learnextra, and our Twitter handle is @learnextra, guys. Make sure that you're in tune and prepared for this show because it's awesome. Already that you guys know that we have an extra site, guys. This site is totally awesome. It has schedules, it has notes, it has the shows. I mean, guys, we will never leave you. I mean it. That site is www.learnextra.co.za/live. Guys, check it out right now so that you know that we're by your side. As Tsepo says, we will always be by your side. That's right, hey?
Yes. That's for grade 10s. Keep on bringing those questions, please. We like
awesome.
those. We like your questions, please.
That we do. We really
Yes.
do. So, guys, if you've joined us on the page already, by now you should have. You can see that we are busy with random acts of kindness, guys. It's really awesome. It's really great. Just to pay it forward, do something good for another person so that you and that person benefits. And, of course, you have to post it on our events page. I'll be posting all these links up for you guys. Take a picture. Tell us what you've been doing. And there's some awesome prizes to be won, guys. These prizes are from Simba. Thank you, Simba. Some of the prizes are from Universal. We've got the Kaya CD. We've got Donald. We've got Onati. We've got Malik. We've got a whole Cheetos bag of chips and a whole party pack. We've got the Mindset t-shirt, just like the one I'm wearing. We've got the lanyards. We've got pens. We've even got a Cheetos notebook there, guys. So you need to enter this competition. There's awesome prizes. We're going to be eating chips for days. And if you guys need someone to share them with, here we are. So make sure that you're in tune for that, guys. We're with Dina today, guys, and we're doing exponents. So get your maths books out. Get everything that you need out, guys, because it's going to be an awesome show. Over to you, Dina.
Thank you very much, Katlego, and to Tsepo as well. Lovely to have that really good starter welcome pack for the show. And yes, it's grade 10, it's exponents, and we're going to briefly look at what the lesson is all about, looking at some of the grade 9 work that you've done, and then we will do some examples, and then obviously look at what is new in grade 10. You obviously jumped into the new grade, so what could be new? Well, some of you may have been asking, we've worked with positive exponents, we've worked with negative exponents, we've worked with zeros in exponent. Well, what about working with a fractional exponent? And that is what we're going to look at a little bit later. What is the definition of a base with a rational exponent? And after that, we'll finish off with some equations. So yes, it's a jam-packed show as per usual. Let's have a look at what the lesson is all about. In this lesson, we're going to learn that to understand exponents is really the foundation for other mathematical topics, including calculus that you will see in grade 12. We will look at the laws for exponents that you've learned in grade 9. We will simplify exponential expressions using the laws learned in grade 9. We will define the meaning of a fractional exponent. We will simplify expressions using rational exponents, and we'll also solve some very basic exponential equations. Let's first of all look at what the laws are for exponents. Well, the first one that we need to look at is the fact that if you've got a to the power of n, it's represented as the product of n number of factors of a. So we basically have got a times times however many factors of a you have. So for example, if you've got a cubed, that means a times a times a. And the laws that you've learned for exponents, I've abbreviated in general form. Let's just go up a little bit. There we go. And that is, many laws that exist don't cover just exponents. They cover other topics as well. But for the multiplication law, if I've got the same base, and we need to look at very carefully that this is a to the m times a to the n, then if you think about it, I'm working with m factors of a, I'm working with n factors of a, so I've really got a total number of factors of m plus n. So if my base is the same, then I've got a law for multiplication. So this is really multiplying powers where the base is the same. So we really are saying, let's just go there, that I am not working at the moment with anything like this. A to the m times b to the n. Can you see the difference? Here, the second power is a different base. So we've got no law for this kind of expression. Okay? So again, the emphasis is on the same base. What happens with division is that you've got, again, the same base, a to the m divided by a to the n, and we then get a difference in the exponents because you've got a certain number of factors there that divide into the factors here, and so your leftover number of factors is m minus n. Now again, there is no law, this is for the division of powers, there is no law for a to the m divided by b to the n. Again, there is no law. Okay, there's no need to make anything up because no such law exists. So it's got to be the same base that we're working with. Then the third law revolves around when a power is raised to another power. Now, think about it. If you've got an example like 2 cubed and I want that squared, then I want to say that that's the same thing as 2 cubed times 2 cubed. So in the end, I get 2 to the power of 6. And 6 is just the product of 3 and 2. So if it's a power raised to another power, I take the product of the exponents. Then I can look at two different factors that are being raised to the power of m. And here I want to emphasize, because we often use this going to that, or we can use that going back to that one bracket factor. So if I have a times b and I'm raising it to the m, it's the same as a to the m multiplied by b to the m. So each of the bases get raised to the power of m. But again, I can rewrite, if my exponent is the same, I can rewrite my product as ab to the power of m. So in this case, I could call this a law around same exponents. If the exponent is the same, then I just multiply my bases. And then we've got that very, very famous a to the 0 is 1, or saying that we've got any base, the power of 0 is always 1. And what you learned in grade 9 was this very important rule that a power or a base raised to a negative exponent, is actually the reciprocal of that very value that you've been given. So a negative exponent is really the same thing as the reciprocal of the base to that with a positive exponent. Okay, so let's just extend the page a little bit here. So what we're saying, I want to expand on this, is if I have 2 to the minus 1, then that means it's the reciprocal of that base. So it's 1 over 2 because the base is 2. In the same way as 3 to the minus 2 would be 1, the reciprocal of that, which would be 3 squared, which would be 9. So a ninth can be written as 3 to the negative 2. How would we get from there back to a negative exponent? You would again take the reciprocal of the base, which is 2, and raise it to a negative exponent. So as long as you're aware that a negative exponent, all it means is a reciprocal of the base, because it came from a division of exponents to get that negative exponent in the first place. So I think the trickiest part about grade 9 was getting to grips with what a negative exponent means and being able to go from 2 to the negative 1 as a half, and 3 to negative 2 as a ninth, and others like 4 to the negative 2 is 1/16th, and being able to play with those fractions from one form to the other. Now, I'm going to ask a very important question before we actually simplify some expressions, because this I find is where people really battle. And that is, we've just looked at this rule that says AB squared is the same as A squared times B squared. So if we've got a product of factors and they being squared, then it's the same thing as saying the square of A, the square of B, and the square of however many factors we have. Question is, what about A plus B all squared? Okay, look at the difference between this expression and this one. This expression is a product of two factors. This expression is a sum of two terms. Is this also equal to A squared plus B squared? And for those of you who've gone through grade 9 and grade 10, you should know that A plus B all squared means the product of two binomials. So we really are referring to A plus B times another A plus B, which really is not going to give us just simply A squared plus B squared. It's also going to give us this outer and inner product of AB and another AB. So we get a 2AB apart from the squares. So there's also a plus a 2AB. So I often find that where learners really battle with the exponents is you don't analyze what's being given. You just jump into it because you see some random exponent and you just climb into the exponent without really analyzing what's happening. Before you jump into any question, you need to analyze, have I got the product or have I got the sum? Because if I've got the sum, then I'm going to deal with it extremely differently. There are no laws for the sum. There are laws for exponents that are governed by multiplication or the two operations, multiplication and division. The sum I will actually have to treat in a completely different way. So the sum actually gives us that. And for most of you, if you ever get into problems with exponents, is because you've applied the exponential multiplication law onto the sum, which has obviously been incorrectly applied. Okay, so let's have a look at some exponential expressions. Let's look at, go up. Let's go here. Right, no, we don't want to go there. Okay, let's just see if there's something else here. Okay, let's go over to Katlego.
Dina, do you want a break?
I'm just looking for my work.
Okay, so while Dina's busy opening her page, I just want to send a quick shout out to the people that have already posted up their random acts of kindness, guys. It's fantastic what you guys are doing. There's Melanie, Megan, there's Cabello, there's everyone, guys. Please make sure that you're posting it today because these prizes are going to go, or they're going to get eaten by me and Tepo here in the studio because we're eyeing them now and we're like, we want those prizes. So make sure that you enter, guys. Make sure. Dina, you ready?
Yeah.
Awesome.
Thanks, Katlehu. We were just looking at some of the examples. The examples on the expressions will be on rational exponents as well. So I'm going to look at the definition of a rational exponent and then come back to just the simplification of expressions. Okay, the concept around the definition of a rational. And to just remind everybody, rational is another fancy word for a fraction where the fraction has got a numerator and denominator that's an integer. And we really want to look at what is the meaning of a to the power of a fraction. So this may look quite tiny. It really does say this, a to the power of m over n. Okay, and the definition of a fractional exponent is that each part of that exponent refers to something else. So the n refers to the root that you're taking, and this m refers to the power that we're looking at. Okay, so for example, if n is our root, then we would have the nth root of a to the power of m. So the numerator will still be the power. So I could write this in a different way as a to the power of m over, or to the power of 1 over n, where n is the root that you're referring to. So the numerator will be the power and the denominator will be the root. And we are specifically saying where a is going to be positive and where m and n is also a fraction. And now we'll look at examples 81 to the power of a half and negative 81 to the power of a half. Now, it's very easy to remember what that denominator means, because if you look at it in terms of the position in the fraction, it's below the fraction line, so it's almost like underground. And roots, if you think of carrot roots or beet roots or whatever, they grow underground. So you'll remember that the root always goes beneath that exponential, that exponential fraction, and the m just stands for the power of a. So if we look at 81 to the power of a half, what we're really saying is that this is the square root. So this is the same as the square root of 81 to the power of 1. But because the power of 1 is exactly the same thing, this is actually asking for the root of 81, which is 9. Now, what about the root of negative 81? So that would be the same thing as the square root of negative 81. Okay. Grade 10s and possibly grade 9s also already could tell me that this is a non-real number. So that's part of the non-real numbers. So we couldn't find a root in the real system, but we can find one in the non-real number system. Okay, so again, this is a root, and because it's the square root, we don't put a 2 there because we don't get the first root. The first root that we get is the square root. So saying this or saying the root of 81 is the same thing, so we don't put the 2 there at all. You don't see it that way. Okay, this is 8 to the 2/3. So 8 to the 2/3. And the definition says that this is my root, so that's going to be the cube root of 8. And 2 is going to be my power, so it's the cube root of 8 squared. Now, you can do that in various ways. You could say that the cube root of 64 is 4, or you could say that the cube root of 8 is 2, and 2 squared is 4. So you could do that in a number of ways. You could also simplify 8 into its prime factors. So we could have that 8 can be rewritten as 2 to the power of 3. We can have that as 2 to the power of 3, which is raised to the power of 2/3. So if you remember the law that says a power raised to another power, we multiply the exponent, so we get 2 squared, which is 4. So there's a number of ways that you can do that. What would it mean to take 8 to the power of negative 2/3? Well, in this case, we would get 8, the cube root of 8 to the power of minus 2. So remember, the negative exponent means you've got the reciprocal, so it's the cube root of 1 over 64, which is a quarter. So it's the reciprocal of that. So if you've got a negative exponent, you would take the reciprocal of the original. So that cube root, remember the root talks about, sorry, the denominator talks about the root, and then this refers to the power. And you wouldn't be able to take a negative root. There wouldn't be such a thing as the negative cube root of something. So the negative of that exponent will always go into the numerator. Okay, over to you, Katlego.
Thank you, Dina. So, guys, it's time for a really, really short break. Before that, Tsepo, how was that?
Okay, that was a great exponential lesson. I've learned a lot. If you didn't, you can still keep on asking those questions. I'll try by all means that you get answered.
Awesome. So Tsepo is going to be on the page, guys. Please chat to him, guys. He is here for you, just like I am. So make sure that you chat to him. He's been in grade 10. He is a mindsetter, so he knows what it's all about. Come on, guys. Jump onto the page and chat to him. We'll see you right after this short break.
See you.
Welcome back, Mindsetters. If you don't already know, well, now you know that we are doing exponents in grade 10 maths today, guys. I hope that you're enjoying the show. Most of you have said, yes, I am on and I'm enjoying it, but there's not enough of you guys. You guys need to call up those friends of yours, call up those classmates, anyone from your street, send a shout out to them to come join us on their TVs and on our page, guys. As you already know, Tsepo is also chatting to us, so you can chat to both of us double, guys. You guys get double today, so make sure that you use it all to your fullest advantage, guys. And make sure also that you are paying it forward. You already know that there's awesome prizes from Cheetos, from Universal, from Mindset, T-shirts, chips, lanyards, and CDs, and everything, guys. So make sure you join us on that, okay? Over to you, Dina.
Thank you, Katlego. Yes, I left you a little while back with the definition of a rational exponent. So let's just recap what we did a little while ago. 8 to the power of 2/3 simply means that I have a root of a base 8 squared, and that root is defined by the denominator, which is the cube root. So this always refers to the root of the number, and that always refers to the power of the number. So let us apply that in the next few exponential expressions that we're going to be doing. Right, first one is up here. We've got, let's just read it aloud. We've got the 4th root of x cubed multiplied by the square root of x to the half. So if I want to simplify exponential expressions, I'm not going to simplify them with different roots. I'm going to simplify them with exponential format, because I have the laws of exponents to help me. Remember, you've got laws of exponents, but you don't have laws of surds. So we will often just translate everything into exponential format. It's much easier. You'll find when you get to grade 12 and you're working with calculus, it's exactly the same thing. You want everything in exponential format because we've got the laws of exponents to help us simplify things. Right, so let us try and put this into exponential format. We've got this equals x cubed is my power, and then I've got my 4th root as the root to work with, so therefore my root goes underneath, and I'm multiplying that by x to the half. And what root do I have over here? What is the root that I'm taking? Correct, that's the power of a half. So in the end, I've got an x to the 3/4 multiplied by an x to, remember the rule for a power raised to another power is just a quarter. And then we've got same base, and I'm multiplying same bases. So I get x to the power of 1, because 3/4 and a quarter is just 4/4, which is 1. So the value is x. Okay, then I can go on to the next question. Right, so again, let's look at a to the power of m over n. What does that mean? The nth root of a to the m, always the root for the denominator. So if I've now got all these surds over here, I'm going to first of all change it into exponential form. So, everybody out there, let's do this together. We've got a cube root over here. So, we've got an a squared times a b to the minus 6, all to the power of cube root. So, it's to the power of a third. And notice what I'm doing now. I'm writing the product that's underneath the root first, and I'm raising it to the root, which is a third. And I'm multiplying that by, what root have I got here? It's the square root, so it's b to the minus 3, and then it's the square root, so it is over 2, because remember the square root is denominator 2. And then in my denominator, I've got something very interesting. I've got a bracket raised to the minus 1, and then I've got the square root. So I work from the outside in. So I'm going to take the square root, which is going to become to the power of a half, and we then have a squared, which is raised to the power of a third, times b to the minus 1, and then I'm raising it to the minus 1, but I have this square root over here. So there's my square root. So my square root is to the power of a half. Okay? Now, you can write it in two ways. You can write it as the whole power raised to the half, or you can just divide the existing power by 2. It really doesn't matter. It's however you see that it works best. Okay? And then at the same time, I have taken this cube root over here. Already, I've changed this number here into a to the 2, and then it's the cube root, so it's 3 there. Okay, so that number's been changed into its third form. That one stayed, b to the minus 1. It was all raised to the minus 1, there it is, and then we had the square root. So there was a lot of changing from third into exponential format. Why are we doing that? Why are we changing the exponential format? Because we can use the laws of exponents. We have got laws to help us simplify exponential expressions. Right, so we've changed the cube root, we've changed the square root, and we've changed. So we've, in today's technological world, we would say we've reformatted the expression. So it's the same expression, but just in a different form. That's all that's happened to it. Okay, so now let's do some multiplication. We've now got, let's just go up a little bit. Okay. We've now got two bases. Can you see the product? And we're raising it to the power of a half. So each of those is going to be raised to the power of a third. We've then got two bases over here, and each one is going to be raised to the power of negative a half. So let's do that together. A to the 2/3 times b to the minus 2 times b to the negative 3 over 2. We're dividing by a to the power of negative a third and b to the power of a half. Okay, now we've got only base a and base b. We're multiplying, we're dividing, so we're going to group those together. So we're going to get a to the power of 2/3. When we divide the same bases, we subtract our exponents. Multiplied by b, same base, add exponents, so it's minus 7 over 2, and we subtract this one. Okay, so when it's same base and we're multiplying the same bases, we add our exponents, so that's negative 4, negative 3 is negative 7, and we're dividing by b to the half, so we're subtracting that exponent. Right, so now it's a simple exercise of a to the 3 over 3, which is just a, multiplied by b to the negative 4, and if I write this as a positive exponent, then I would get a over b to the 4. Okay, so a lot of work going on there. We first format the surd to become an exponent, and then we use our exponential laws. And I would suggest keep your exponential laws next to you all the time so you can verify if I'm multiplying, if I'm dividing. Remember, there are no laws for addition. For addition, you add the terms. There are the algebraic laws for terms, but there are no laws that govern the exponents around terms. Right, and then we've got simplifying this square root. Now, this is very interesting because we haven't come across a question where we had to deal with terms. So we're going to first of all treat this fraction and deal with what's going on in there, and then I'm going to come back to that square root. So sometimes there is wisdom in just delaying this process slightly, keeping the square root there, and sometimes we can go straight into reformatting the square root. So for now, I want you to all look. I'm actually going to rewrite this so that you're happy with what it's saying. It's saying take the square root of a numerator that has got a 3 to the power of x plus 2 minus a 3 to the x. And then we're going to add 1 onto that, over a 3 to the power of x minus 1. Okay. Now, earlier on we said that if the bases are the same, so if we have 3 to the x times 3 to the 1, the law says same base multiplication. We keep the base, we add the exponents. Okay. Now, we're going to go back and say that if you've got the sum of exponents, then it must mean that it can be rewritten as 2 separate bases. So 3 to the x multiplied by 3 to the 1. The sum of exponents implies that I've got the product of factors that have got the same base. Okay. And we're going to use this quite a lot in the next question because I notice that I have got terms. I've got a fraction with terms, and I cannot divide unless I have one term divided by one term. So I basically have to get this numerator to become one term. And the only way I can do that is if I factorize. What you cannot do is you cannot take a base and leave the exponents hanging. That doesn't work in maths. If you're going to have a common factor, or if you're going to factorize an exponential expression, you have to take the base and the exponent at the same time. So what we're going to do to help us is we're going to rewrite this over here. Let's just get a white pen. There we go. I'm going to rewrite it as 3 to the x times 3 squared. So sum of exponents means they come from the same base, minus 3 to the x, all over sum of exponents means they come from 2 separate exponents, two separate bases, okay? And now can you see that I've now located a 3 to the x, which in both terms is common. So if I take that out, then I would get a 3 to the x that I'm going to take out as a factor, and I'm left with, from the first term, I'm left with a 3 squared, which is a 9, and I'm left with a 3 to the x, which is a 1, over 3 to the x multiplied by 3 to the negative 1. And I'm still sitting with this plus 1 at the end. Okay? Now, I've got a 3 to the x that can be divided in 3 to the x. It's one term divided by one term. That goes in once. And I'm left with 8 divided by 8 divided by a third. Remember I said earlier you need to work with 3 to the negative 1 as a fraction, as a reciprocal of 3, divided by, and then I've got this plus 1. So what's 8 divided by a third? That's just equal to 24, which plus 1 is 25, and so we get that was a 5. And in this case, I didn't really need to resort to my rule for a third because I was actually working with the expression inside it first. Okay, right, let's see what our last example looks like. Prove that this fraction is independent of x. Okay, Now I want you to look at very carefully how it's got terms in the numerator and it's got terms in the denominator. And whenever that happens and I'm trying to divide, I need to factorize. So straight away, I cannot do anything without factorizing. And if I'm going to factorize exponential expressions, then I first have to split that x plus 1 into its separate bases so that I can see exactly what the common factor is. So if I take that as 2 times a 3 to the x times a 3 plus a 3 to the x times a 3 squared, then I'm left with in the denominator a 2 times a 3 to the x times a 3 cubed plus a 3 to the x. Okay, then I've got that is common in my numerator, a 3 to the x is common in my denominator, and let's factorize that nicely. So we've got a 3 to the x common in the numerator. So I'm left with 2 times 3 as my first term, which is 6, plus a 9. And I'm dividing it by a 3 to the x. If I take that out, I'm left with a 27 times 2, which is a 54, and a plus 1. So we then have that now I can divide a 3 to the x, 3 to the x. It's very, very important that we are dividing one term by one term. So I get a 55 as my denominator. And that is just, if we divide by 3, it would be 5 over 11. So we get an answer, which it said earlier, proved that it's independent of x. So the answer of 5/11 is certainly independent of x. And I think we'll leave it there for now. And
I think it's time for a break. Yeah, so you guys can get a glass of water going. You guys have done a lot in this show, but I need your questions, guys. I need you guys to keep chatting to us so that we know where you're at and how grade 10 is treating you and where we need to help you and push you that extra mile. So join us on the page, guys. Do not move off your seats, okay? See you just now. Welcome back, Mindsetters. I hope you're all enjoying the show. Grade 10 exponents, guys. I know that this section is one of those sections that at the end of the year, you're going to be like, thanks to Mindset, I aced this section. So you guys really, really need to ask us questions. And my guess is that you're not asking questions because you actually understand. And I really do understand that because you guys are Mindsetters and you're actually just ahead of the rest. So make sure that you tell us that you're understanding so that we also know that, wow, our Mindsetters are actually so awesome. They actually take the cup for the best maths people in the world. So let us know, guys. We really want to hear from you. Okay, over to you, Dina.
Thanks, Katlego. Yes, let's finish off with our last little bit of exponents. But I really want to challenge you to think about some issues that we've been raising this afternoon around negative exponents and rational exponents. And so I'm going to test you by just asking whether you think a statement is true or false. And I'll come back in the last 2 minutes and just see how you've done. So the first one is, do you think that... So it's question 3a. Do you think that 2x to the minus 2 is equal to 1 over 2x squared? Do you think that's true or do you think that's false? And once you post your answer on the page, we'll have a look at how many of you were able to get it right. Is it true or false that 2x to the power of negative 2 is the same as 1 over 2x squared? And then the next one is question 3b. Is it true or false that 9 to the power of a half minus 4 to the power of a half, all squared, is equal to 5. Is that true or is that false? Okay, so 9 to the power of a half minus 4 to the power of a half, all squared, is that equal to 5? And the previous one was, is 2x to the minus 2 equal to 1 over 2x squared? And then Katlego will let you know a little later whether you've been certainly on target, whether it's true or false, and I'll look at those answers shortly. Right. Let us go on to the key concepts around exponential equations. And when solving exponential equations, what we're saying is that the exponent is going to be the unknown. So we've actually got an equation where we don't know what the exponent is. So we are going to make use of the following property. we're going to say that if I've got an a to the x is equal to a to the m, then if my bases are the same on either side of the equal sign, we are saying that x must be equal to m. So let's look at an example. If you said that you had 2 to the power of x, for example, and you said that that was equal to 8, all right? Then I'm saying that 8 is the same thing as 2 cubed. And if that's 2 cubed, then it can only mean that my x must be cubed. Otherwise, it's not going to give me 8. So if you look at those bases, they're both the same base. So we're saying x must be equal to 3. The exponents must be true. So that's the property that we're going to utilize, that the exponents must be equal if we've got the same base on either side of the equal sign. Okay, so let's look at an example. Okay, we're going to solve for x, and we've got 4 to the power of x minus 1 is equal to 1/8. Okay, and our job is to get it to the same base on either side. Now, with any exponential work, you'll find that because we want to work with the same base, because the law about multiplication of exponents uses the same base, we're going to try and rewrite numbers into their prime factors, which would mean writing bases as powers of 2, powers of 3, powers of 5. Those are the most famous, or the first 3 famous prime numbers. So we will try and write every base in that number. So a 4 is exactly the same thing as 2 squared. So we can raise 4 to the power of x minus 1. It's the same thing. And we could write 1/8 as, what exponential law could we use to write 1/8? 1/8 is the same as 8 to the minus 1. And so that would mean a 2 to the minus 3. And you should be able to be very flexible with those powers. So an 1/8 is 2 to the minus 3, a quarter is 2 to the minus 2, a half is 2 to the minus 1. You should be able to say them like you learnt your tables in grade 3. You should be able to be doing the same thing with negative exponents and giving yourself things like 2 to the power of negative 5 is 1 over 32, 2 to the power of negative 6 is 1 over 64, so that you really are very good and very flexible with those numbers. Right, so we now have that this base, well, it's not really tidied up. Let's just tidy it up a little bit. So that would be 2x minus 2 is equal to 2 to the minus 3. And then we're sitting with a situation where we've got same base on both sides. So therefore, our exponents must be the same. 2x minus 2 must equal to minus 3. And we've got 2x is equal to negative 1, so x is equal to negative 1/2. So we've got that exponent is to minus 1/2. Now, with any equation, you should always not feel satisfied. You should say, I really want to know if that is truly the solution to the equation. You should go back and check the validity of that solution. So if we go back to the equation, and we take that x value as minus 1/2, then we could, that's 2 minus 1, okay. 2 to x, I'm just checking the calculation, 2 minus 2, okay. We should be able to check that this minus 1/2 here would give me a 4 to the minus 1/2 minus 1, which would be a minus 3 over 2. And we get on this side an 8, which is 2 to the minus 3. So let's see if we get that same value on this side. Remember, 4 as a prime base would be 2 squared. So we'd have 2 squared to the power of minus 3 over 2. And look what we get. 2 goes into 2, and we're left with a 2 to the minus 3. So in fact, it is the solution. So if it wasn't going to give me the solution, I knew I could have made some errors and could have gone to fix those. All right, and then the next one. Same thing. I'm going to try and get the same base on both sides. So that's going to be 2 to the power of minus 1, so it's minus x squared minus 9 is equal to 2 squared to the power of x minus 4. So let's tidy it up a little bit. So it's 2 to the minus x squared minus 9 is equal to 2 to the 2x minus 8. Okay. see what we've done? We've created a situation where we've got the same base on both sides. So we're now just going to compare the exponents and say, for these two sides to be the same, my exponents must also work out to be the same. So negative x squared minus 9 is equal to 2x minus 8. So we land up with a little quadratic equation, which gives us minus x squared minus 2x plus 8 would be minus 1. So we've got x squared plus 2x plus 1 equals 0. So x plus 1, do you recognize the perfect square trinomial? So x is therefore equal to minus 1. Again, yes, we've got an answer, but let's go and test whether it works. So x equals minus 1, we're saying is our solution. So let's try a minus 1 in here. If x is minus 1, then we'd get a half to the power of minus 1 squared is 1. So 9 and 1 is 10. And we're getting a 4 to the power of a minus 1 minus 4 is minus 5. Is that the same thing? It's a half to the 10. Well, 4 is the same thing as 2 squared. So that to the negative 5 would give me 2 to the negative 10, which is the same thing as a half to the 10. So in fact, the negative 1 is a solution because I'm getting the same thing on both sides. Okay, so I posted a little problem to you a little bit earlier, and we looked at whether these two questions are true or false.
And we have some answers, hey, Dina.
We have. What
We
do they
do
say
indeed.
about 3a? 3a,
Actually,
true or
most
false?
of our grade 10s say A is true.
They say A is true. Okay, well, let's have a look at it
Let's have a look.
in a moment. Okay, let's look at it as we go along. All right. This expression over here actually says 2 times x to the minus 2. Now, if I say 2 is being multiplied by that factor over there, then you'll agree that this 2 is being raised to the power of 1. And that actually forces me to say that this is the same thing as 2 times 1 over x squared. So if that is the case, my value is 2 over x squared. So my 2 is in the numerator and x squared is in the denominator. So unfortunately, mindsetters, it's not true. It's false. Okay? Let's have a look at why you have said that. You may have suggested that this minus 2 is also the power for the 2, and it's not. If I wanted this to come out as my answer, then this is where it comes from. It comes from 2x to the minus 2, to the minus 1, and that one's to the minus 2. So that you could take the reciprocal of 2, there it is, and you could take the reciprocal of x to the minus 2, there it is. Okay, so be very careful with, are there brackets around these factors, or are they standing alone? And look at how you read them. I'm reading this as 2 to the power of 1, multiplied by x to the negative 2. So the negative exponent, this negative exponent, is only operational on the x, not on the 2. So the 2 stays in the numerator. It's the x to the negative 2 that becomes the reciprocal into the denominator. So be very careful. So if you wanted to have changed both the 2 and the x, you would have to have 2 to the minus 1, and you'd have to have an x to the minus 2 as well. So both of these would then go into that denominator over there. And then you could also work on an alternative. What about 2? X to the minus 2. What would that look like? If you had to change it in as a fraction, what would it look like? So you can play around with those, and if you can really grasp that, then you're A for exponents. Okay, and then the second one, what do the mindsetters have to say?
The second one they say is false.
Very good, mindsetters. Let's look at why it's false. Okay? Earlier on, I said to you that if you've got terms, it doesn't mean that you're going to square the first and square the second. So if you had done that, if you had squared this value, you'd get 9 minus 4 is 5. But that's certainly not true. That's false. Okay? Reason being is that we said this afternoon that this means the root of the number. So this would be the square root of 9 minus the square root of 4. and we are going to square that. So we get 3 minus 2 that we are going to square, and we get 1 squared, which is equal to 1. So it certainly is not equal to 5. So again, I think my repetition over and over has been, are you working with terms or are you working with factors? So if you had 9 to the half multiplied by 4 to the half, and you were squaring that, that would be 9 times 4, which is 36. So you could take the square of both, but you can only do that when you've got a product. So it's a product versus having a sum. The sum, you need to first get the sum, and then you'll square it, or you will use the binomial rule to square that. So I'll leave you with that mindset, is to go and keep thinking about exponents, and all the best for the rest of the week.
Thank you for that, Dina. Guys, thank you for such an awesome show. I always say it's so good to make mistakes. Do you know why? So that you never make them again. It's always good to actually know where you went wrong so that you can correct it and so that you never do it again. Guys, that's an awesome part about being with us today, because now you can correct everything that you needed to correct from school today and keep going with it, guys. Keep going with maths, because it is really awesome, grade 10s. It was such an awesome show, guys. Keep being on the page and call all your grade 11 friends, guys. We enjoyed it so much. From us at Mindset, bye-bye.
Let's just go up a little bit. There we go. And that is, many laws that exist don't cover just exponents. They cover other topics as well. But for the multiplication law, if I've got the same base, and we need to look at very carefully that this is a to the m times a to the n, then if you think about it, I'm working with m factors of a, I'm working with n factors of a, so I've really got a total number of factors of m plus n. So if my base is the same, then I've got a law for multiplication. So this is really multiplying powers where the base is the same. So we really are saying, let's just go there, that I am not working at the moment with anything like this. A to the m times b to the n. Can you see the difference? Here, the second power is a different base. So we've got no law for this kind of expression. Okay? So again, the emphasis is on the same base. What happens with division is that you've got
Hello guys, welcome to Learn Extra Live. Wow, I'm excited to be here. This next to me is Tsepo. Hi Tsepo, how are you?
Fine, thank you. How are you?
Great, great. You guys already know that we have our presenter search. Tsepo is part of the top 10, guys. Like, this is awesome. How do you feel?
Yes, I feel so honored. You know, actually, I'd like to thank my friends on Facebook. Thank you for voting for me. Thank you. I'm here because of you. I don't know how to thank you again.
That's awesome, Tsepo.
Yes.
Thank you for that, hey. So you guys, thank you to you guys for bringing Tsepo on the show, because he's excited to be here. I'm excited to be here. Tell us a little bit about yourself, just so we know,
So, okay, this is Tsepo. Tsepo is me. I'm from Pretoria in the north of Maopane. Hello, if you know me. Yeah, I'm quite an open person, vibrant person, you know, enthusiastic about education, and I'm willing to learn more. So I'm a mindsetter. I've been a mindsetter for quite a while.
Oh,
so
wow.
I'm willing, since I completed my matric last year, I'm still willing to be a mindsetter again. this
Oh,
year.
wow, that's fantastic, Tipo. You
Yes.
see, guys, he wants to be a mindsetter for life. And he says mindset really did help him in matric, in grade 10, in grade 11, whatever. So you grade 10s need to stick with us because then you're going to come this far. And you've just finished matric, hey?
Yes, I did.
And
it was
how-
Later, what is the definition of a base with a rational exponent? And after that, we'll finish off with some equations. So yes, it's a jam-packed show as per usual. Let's have a look at what the lesson is all about. In this lesson, we're going to learn that to understand exponents is really the foundation for other mathematical topics, including calculus that you will see in grade 12. We will look at the laws for exponents that you've learned in grade 9. We will simplify exponential expressions using the laws learned in grade 9. We will define the meaning of a fractional exponent. We will simplify expressions using rational exponents, and we'll also solve some very basic exponential equations. Let's first of all look at what the laws are for exponents. Well, the first one that we need to look at is the fact that if you've got a to the power of n, it's represented as the product of n number of factors of a. So we basically have got a times a times a times however many factors of a you have. So for example, if you've got a cubed, that means a times a times a. And the laws that you've learned for exponents, I've abbreviated in general form.
So that you and that person benefits. And of course, you have to post it on our events page. I'll be posting all these links up for you guys. Take a picture, tell us what you've been doing, and there's some awesome prizes to be won, guys. These prizes are from Simba. Thank you, Simba. Some of the prizes are from Universal. We've got the Kaya CD, we've got Donald, we've got Onati, we've got Malik, we've got a whole Cheetos bag of chips and a whole party pack. We've got the Mindset t-shirt, just like the one I'm wearing. We've got the lanyards, we've got pens, we've even got a Cheetos notebook there, guys. So you need to enter this competition. There's awesome prizes. We're going to be eating chips for days, and if you guys need someone to share them with, here we are. So make sure that you're in tune for that, guys. We're with Dina today, guys, and we're doing exponents. So get your maths books out. Get everything that you need out, guys, because it's going to be an awesome show. Over to you, Dina.
Thank you very much, Katlego, and to Tsepo as well. Lovely to have that really good starter welcome pack for the show. And yes, it's grade 10, it's exponents, and we're going to briefly look at what the lesson is all about, looking at some of the grade 9 work that you've done, and then we will do some examples, and then obviously look at what is new in grade 10. You obviously jumped into the new grade, so what could be new? Well, some of you may have been asking, we've worked with positive exponents, we've worked with negative exponents, we've worked with zero as an exponent. Well, what about working with a fractional exponent? And that is what we're going to look at a little bit.
What's
awesome.
that?
I enjoyed. Everything was going cool. With Mindset on my other side, things were easy.
Oh, that's fantastic. We're so excited to hear that. And you
Yes.
mindsetters already know that we will never, ever leave you, which is why you should join us on the page, guys. Today, Tsepo is actually going to be on the page to you guys. Chat to him. He's a mindsetter. He knows a lot.
Yes.
Chat to him about everything.
Yes.
Exponents, because that's what we're going to be doing today. Anything that you want to know.
Yes.
Ask him how it was to be in our Mindset studio and to meet all of us. So yeah, guys, chat to him on the page www.facebook.com/learnextra, and our Twitter handle is @learnextra, guys. Make sure that you're in tune and prepared for this show because it's awesome. Already that you guys know that we have an extra site, guys. This site is totally awesome. It has schedules, it has notes, it has the shows. I mean, guys, we will never leave you. I mean it. That site is www.learnextra.co.za/live. Guys, check it out right now so that you know that we're by your side. As Tsepo says, we will
Yes.
always be by your side. That's right, hey?
Yes. As for grade 10s, keep on bringing those questions, please. We
That's
like
awesome.
those. We
love
like your questions, please.
That we do. We really
Yes.
do. So, guys, if you've joined us on the page already, by now you should have. You can see that we are busy with random acts of kindness, guys. It's really awesome. It's really great. Just to pay it forward, do something good for another person.